Maddie, what day are we on?
Maddie's not here.
I know, Sammy. It was a joke. I was going to reply for her. Day 5. I know. Let's try again. Maddie, what day are we on? Day 5. Thanks, Maddie. Sammy. Ruined my fun. I've tried not to lie to you since the first day of systems. This is teaching you to think. And some of you it's hurting, I think, to think this hard. Maddie, what day are we on? Maddie. No, stop!
Oh, yeah.
There's a camera. What day are we on? No, Maddie, look, Maddie.
5.
Day 5, woo! Welcome.
I get excited for 1 second.
You got so excited, Maddie, you almost ran. Like, I didn't know if you were trying to tackle me or what you were doing, but I'm glad you didn't get into the camera, because then we would have had to start again and then go from there. But Maddie, you ran. That was awesome, buddy. Like, you were so excited to see me. I want all of you to be like that. When you see me, you're like, woo! Like, Maddie, that made my day. Thank you. Like, this is why we teach. Maddie thought I was giving her a high five instead of telling her how many days we were on, and she ran at me. I'm not gonna lie, like I was a little intimidated because like students don't usually run at me unless they're upset. But Maddie, my heart is filled with joy right now. And actually, you're on the video even before you came into class.
Wow.
I know. I missed you. I said, Maddie, what day are we on? And then Sammy goes, Maddie's not here. I was like, but I said, so I asked again. I said, Maddie, what day are we on? I went, day 5. That was you. Good job.
Maddie, you're reliable. We know you know the day.
I have no idea where I was going. I don't even remember what I was saying.
You said I'm going to tell you the truth.
Oh, yeah. You're not going to use systems. Almost, I would say 97% of you will not use systems after you pass Algebra 2.
What are you teaching them?
Well, again, because I'm teaching you how to think.
Okay.
I want to teach you a thought process. Can you think for your own? And that's a very generic answer. Let me go a little bit easier. Because I have to. Because it's going to be on the map tests and they worry about that kind of stuff. You'll need it in algebra. Like, you will have this stuff in algebra.
Are we redoing day 5?
No. Are we on day 6, Maddie?
Yeah, we're on day 6.
Maddie, this is why I love you, Maddie. Thank you, Maddie.
Yay.
I'm so glad you're here. We would have been on day 5 and nobody would have known the difference. Thanks, Maddie.
Okay.
So, we've done 2 ways of solving so far. So, first off, we just did a warm-up and we solved by graphing. When we were solving by graphing, what did our equations look like? What did our equations look like to solve by graphing?
They were simplified.
What do you mean by simplified?
They were the variables included.
Yeah. For graphing, both equations had variables isolated. But even more so than that, what form did we really want them in? What form did we want them in to graph? And I've only said these 3 words 193 times.
Starts with an S.
Alyssa?
Slope-intercept form?
Yeah. So we like graphing when our equations are in slope-intercept form. But again, this is the least accurate. Okay? I choose, personally, not to use graphing. I'm also a little bit better at solving equations in math. Most of you are like, graphing's easy. Because most of you did not like substitution. When did we use substitution? Maddie?
When only one of the variables are isolated.
Yeah. Very good, Maddie. one equation had a variable isolated. This takes, and I'm not going to lie about it, lots of work, very accurate. That's not a J, that's a semicolon. Just, I don't know how better to make a J or a semicolon. Now, today we get to my favorite method. Because more often than not, you're not going to have your equations in slope-intercept form. More often than not, one of your equations isn't going to be isolated. So we are going to start the elimination method. Which I call math magic. The reason why I call it math magic is because somebody is going to ask at some point, Mr. H, why does this work? And I'm going to say, well, it's magic. Because I can't explain it to you well enough in terms that you'll understand. We are manipulating equations. Just like we solve equations where we use the inverse, but we take away from one side, we can take away from the other side. Well, we're doing things to equations that are going to change everything about it. It looks like magic. It's a disappearing act. The elimination method used when both equations are in standard form. Standard form, unlike slope-intercept, which was y equals mx plus b, standard form is ax plus by equals c. Now, how does elimination work? Well, either both x's or both y's need to be the same. And now I'm going to let you get caught up, copy all of that. I've got something in my throat and I need to get a drink. But then we'll see an example. Dancing in the dark, kneeling in my arms, lifted on the grass, listening to our favorite song. You want me to put on Bruno Mars over there?
Sure.
Not gonna lie, I was listening to a musical this morning.
Which
And
one?
Jesus Christ Superstar.
Oh, you like that?
I do like that one.
Yeah.
And I had a couple kids coming in as I'm screaming. Mostly just singing.
Yeah.
Didn't notice them at first. They're just standing at my door looking at me funny. It's fine. Really, that's a musical that I've listened to a lot. At Just Peck, probably the Green Coat. Like that. Peek. It's like a game with my son. Peek. If we had a big camera that showed the entire board, I wouldn't be able to play. I wouldn't be able to play peek.
You would be able to play.
No, because it would actually be a good camera where I could upload things that would
And
actually.
you can move around the room.
Yeah.
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 That'd be cool.
I know. Would be nice.
That would be nice.
Hope you're listening.
Like a chair with a back to it, wouldn't you?
I would like a chair with a back to it. I'm gonna bring that one up. I got a chair without a back to it. It's like, hey, Mr. H, you're garbage. Take this piece of garbage chair. Here you go. And that's, I feel like that's what they did. They said, listen, it doesn't have handles,
It doesn't have a back.
doesn't have a back, doesn't have armrests. It's good for you. You're trash. Here you go. Geek. So, let's start off with an easy problem. And I'm going to say easy problem, and I promise you, you're going to look at me and be like, what makes this easy? And I'm not going to have an answer. 5x minus 6y equals negative 32. And 3x plus 6y equals 48. First and foremost, the key to elimination is making sure that everything lines up. Mr. H, what do you mean? The x's are over top of each other. The y's are over top of each other. The equal signs are in the same place. My constants are in the same place. Does everybody understand when I say they must line up? These are in standard form. There's a coefficient and a variable, and a constant. Coefficient, variable, constant.
Hey, Mr. H.
Hey,
Do the variables have to be the same variable though? So like 5x and 3x, right?
yeah, they have to line up. The x's have to line up, the y's have to line up. Yep. Is that what you're asking?
Yes.
Yes. So now we come down here. Elimination says either both x's or both y's need to be the same. 5x, 3x. Are those the same? Are 5x and 3x the same number? No. If you look at that and go, yeah, 5 and 3, those are the same. I'm gonna be like, cool, give me $5. It's the same as $3, you're fine. Okay? What about 6y and 6y? Are those the same? The 6's are the same. Bingo. Right there, I know that I can eliminate. But we need to look at the signs. Negative, positive. Okay, and for these, I'm not going to put my funny bracket because I like to do a little bit of work out to the side. When my signs are different, this is going to be tough. When the signs are different, we are going to add. And notice how I put a big old plus sign out in front of those equations. The goal of elimination is to eliminate one of the variables. We want it to disappear, hence, math magic. You see it, now you don't. And you can add a little bit of jazz hands if you want. Okay? So we are going to add straight up and down. 5x's plus 3x's. Jackson, how many x's?
5 plus 3.
Correct. How many?
Oh, that'll be 8 x's.
So this is 8x. Negative 6y's plus 6y's. If I have negative 6 and I add 6, how many y's do I have? Go ahead, Grego.
0.
0. Do I need to put a plus 0 here?
No.
No. Just like equations, that is gone because it's become 0. Equal comes down. An equal plus an equal is still an equal. Negative 32 plus 48. What is negative 32 plus 48? Well, they're different signs. That means we are going to forget the signs and subtract 16. Which number is bigger? Well, 48, so it's a positive 16. Wait a minute. How easy is this equation? 8x equals 16. Can we solve that, Swill? We can. Can you? Show me. Go.
How?
Well, talk to me. By showing me, I will pretend to be your arm.
Okay.
So tell your arm what to do. I want the neurons to fire from your brain to your shoulder, to your elbow, to your wrist, to your fingers, and then I'll write. Go.
Okay. Divide 8x from 8x.
Not 8x, but just
8.
8.
And then do the same thing with 16 divided by 8.
Good. What is 8 divided by 8, Swill?
0. Or 1.
1. 1 what?
1x.
1x. 16 divided by 8 is
2.
2. You do know, Swill. You just need some confidence, brother. You do so well. I'm proud of you. The neurons fired very well. X equals 2. We now have half of my solution. Because what does our solution have to be for any system?
Wait, does it have to be negative? No.
No, ma'am. Because a negative plus this positive. The positive is bigger, so it's going to stay positive.
Oh, wait, never mind.
Okay. So what type of solution do I have to have for a system? Alyssa?
In order to.
An ordered pair. So right now, we only have half of my solution. 2 comma something. We need to find the y. So just like substitution, we're going to substitute it in to either equation. It does not matter. It does not matter which equation we are substituting it into. Choose one, top or bottom. Abby? Top. So I'm going to take this equation and bring it down. 5x minus 6y equals negative 32. What are we going to substitute into this equation? What do we think? Go ahead, Brennan.
X.
X. X equals 2. So I'm going to say 5 parenthesis minus 6y equals negative 32. What is x? Well, x is 2. We have to solve the equation. So if you don't know how to solve, you're still going to struggle. This gives me 10 minus 6y equals negative 32. 10 minus 6y, well, this is a positive 10. I must subtract 10 from both sides. 10 minus 10 is 0. All of this comes down. The sign, the coefficient, the variable. Negative 6y equals negative 42. And I feel like it's not going to be the elimination portion that you have trouble with. It's going to be the solving. So now I have negative 6 times y. I divide by negative 6 because the inverse of multiplication is division. Negative 6 divided by negative 6 is 1. 1 what? 1y, Mr. H. I know you guys are so bright. Negative 42 divided by negative 6.
7.
Positive 7.
I did.
So now you...
I did the 3x.
So you did the bottom equation. It's still going to work. And now I have my solution of 2, comma 7. I'm going to give you a minute to copy that down. Okay, that's just one example. Does elimination get harder than this? Yes, but we're not there yet. I'm going to try to make one up in my head. Yeah, we're going to see how that goes, right? Let's see if I can be smart. So you guys keep copying down. I will come over here and make one up. Oh man, come on, Mr. H, you got this.
Mr. H,
Yo,
are you going to give us an example of when the signs are the same?
you know Mrs. Armstrong? I am.
I'm excited for it. Like, Mr. H is something that's totally new to me too. I probably learned it in high school. Algebra and algebra too, but I don't remember. I remember systems, but I don't remember this elimination thing. So it's kind of, I think it's kind of slick.
Oh, yep, we're gonna see how it goes. It's gonna work. Actually, let's make it. We'll make it even tougher. We'll look at this. Good, good, good. Love it. Now, are we done with the example that's copied down over here? I would hope so. If not, Ralph. Copy down this problem. It says 7x plus 10y equals 4. 7x minus 4y equals negative 24. And again, I keep putting the bracket because that's what I'm used to seeing, but it doesn't need to. It's going to say solve the system. I'm going to tell you to solve the system by elimination. Now, this is where I differ from a lot of other teachers. they would add a step here. I don't care. That first example we added because the signs were different. I don't care if you have to subtract. So some teachers will say, you always have to add an elimination. That's how a lot of old school books taught. I am more of an old school teacher, but you don't need to always add. You can add or subtract, and I'm going to show you why. So, are we lined up correctly? That's the first thing that I want you to take a look at. Look at this and tell me, are my x's in line? Are my y's in line? Are my equal signs in line? Are my constants in line? Brooklyn, are we good in line? Yes. Elimination method. One of our variables needed to be the same. Seth, you ready, man? Are my y's the same?
No.
No, because 10 and 4 are not the same. Seth, are my x's the same?
Yeah.
Yes. Are they both positive, both negative, one positive, one negative? What are they?
Both positive.
Both positive. Think about what we are doing. We are eliminating. Eliminating. I want to eliminate the things that are the same. If I add, would that help me eliminate my x's? Emma, why not? You're saying no, but why? If I add, what happens? That would give me 14x, which doesn't eliminate it. What do I need to do if the signs are the same? Subtract. Notice how I put a big subtraction sign out there, because watch what happens. 7 minus 7 is what? Mason, what's 7 minus 7?
0.
0. I've eliminated my x's. Okay, listen. I made this one tough. 10, and here's how, I physically want you to take your hand, take your pencil, and touch each thing that you're doing. 10 minus negative 4. So now watch what I'm going to write. 10 minus negative 4. What happens when we have those two negatives? And I see a lot of hands. Good. Maya. It becomes a plus. So again, listen. Watch what I'm doing here. 10 minus negative 4. It's not just 10 minus 4. You have to include that sign out in front. 10 minus a negative 4. You said we're going to add. Well, what's 10 plus 4? 14. Y. Equal sign just drops down. Without me telling you, I'm going to give you 7 seconds. Tell me what the last number is going to be. What's my constant going to be? So, take a second. Then I'm going to call on Abby, but I want to see how many hands show up to see who feels confident with what that last number is going to be. So, 3, 2, 1. If you think you know what this last number is going to be, put your hands up. I'm not going to call on you. We already know I'm calling on Abby. So I just want to see who feels confident with it. Okay, Abby?
Negative 20.
Negative 20? How did you get that? You did 4 minus 24, which would be negative 20. 4 minus 24 would be, but it's 4 minus a negative. What happens with the minus a negative? It becomes? So what's 4 plus 24, Abby? There you go. Okay, show of hands. Who had 28? Abby, thank you for being courageous and trying them. Good. Everybody with me? Can we solve this? Is this an equation that we can solve? We find a balance point. Brooklyn, 14y equals 28. What inverse operation do I need to use to get y isolated? Division. What do we divide by, Brooklyn? Very good, honey. Divide by 14. 14 divided by 14 is 1. 1 what? 1y. 28 divided by 14 is 2. So now y equals 2. Woo woo! Already, we know half of my ordered pair. Because my ordered pair has to have what, Isabella?
The X and the Y.
And?
Oh, parentheses.
And parentheses, right, Isabella?
You were just talking about that. I was like, what do you want me to say?
Parentheses. So, it does not matter. Now you're substituting into either equation. I personally choose the equation that has as few negatives as possible. I don't like negatives. So I'm going to choose this top one. 7x plus 10y equals 4. What are we substituting into, Caleb? What do we know right now? We know y is 2. So we're going to substitute into y. 7x plus 10, we don't know what that is yet until we look here. Y is 2. And again, this is where you have trouble. Have to solve the equation. 7x plus 20 equals 4. Ooh, and this is where, darn it, it worked for the first number, it did not work for the second. You're going to get a fraction. This will not happen usually. I made one up and I screwed up. So we subtract 20 from both sides. That gives me 7x equals negative 16. Why negative? Well, they're different signs. The 20 is a bigger number. It has the negative with it. It keeps the negative. Again, I screwed up. You will not get fractions on homework. You will not get fractions on tests. What do we have to do to isolate the x? Divide by 7. 7 divided by 7 is 1. 1 what? 1x. Now listen, could you divide this and get a decimal? Sure. We're not going to. We're going to leave it in simplest form of negative 16/7. Now, is this correct? Absolutely. Would you want to graph and try to see that something's at negative 16/7? Would you even know where that's at on the graph?
No.
So, the reason that systems have other ways besides just graphing, not only is it accurate, but think about who's using this. Scientists are using this to find perfect numbers. They need to know exactly where something's at. Let's try one more that I'm not going to help you on. Let me get one. I can find one. Where do I want to solve? Okay. Here we go. I'd like you to try this as much on your own as possible. 10x plus 25y equals negative 110. 10x plus 3y equals 22. Talk it over with your little group. See what you can get. I shall be back.
Sorry, I'm so full.
So if you have a negative 110 and a positive 22, are your signs the same or are they different? They're different. So you're going to forget about the signs, you're going to subtract. So what's 110 minus 22? You're going to have to actually. Okay, so Abby says that it's negative 88. Why is it negative, Abby? There. Yeah, because the bigger number's negative. Okay, now you can evenly divide that. You're welcome. Thank your teammate over here. You did. You know what though? Did you subtract or did you guys add? You have to subtract, so it's gonna be negative 110 minus 22, so they have the same sign. So it's, what would it be? It's not gonna be positive. You have, are the signs the same or the signs different? So,
Oh, wait, no, it's two.
I got you. I'm gonna show you real quick here. Negative 110 minus 22. If our signs are the same, we add those two numbers
So adding these? Yes.
and we bring down the same sign. Okay? Thank you, Sam.
Yeah, I'm so confused.
So where's 25 minus 3?
You mean subtracting? Yes.
I'm slow. 22 doesn't go into.
Okay.
Yeah, it does. It'll go in there evenly.
I want to do absolutely nothing besides write the problem down. I want you to tell me everything that I need to do. The only thing that I'll say is, first step. What is our first step always? Always. What's going to be our first step for elimination?
I don't know.
Sammy?
See if they're aligned.
See if they're in line. X's, Y's, constants. Okay. Somebody step up. Tell me what we're doing. Alyssa.
Well, we have to see if any of them are the same.
Okay.
And 10x and 10x are the same.
Good.
Because they're positive.
So Alyssa just said 10x and 10x are the same and they're positive. Okay? I'll take that. Next, Evan.
You have to subtract the 10x.
So wait, what are we going to do? Just subtract.
Yeah, subtract.
So we're subtracting this whole system. Go ahead, walk me through it.
Right, so you subtract 10x from 10x.
Good, which is?
0.
Do I need to write a 0?
No.
Okay.
And you take 25 subtracted by 3y. And that gets 22.
22.
Y.
Y. Okay.
And then you get negative 110, and you subtract that by 22, but that turns into a positive 110, so you get 132.
Okay, so you do get 132, but it's not going to be positive. If I'm at negative 110 on my number line, and I take away 22 more, it's going to be negative 132. Okay, so far I'm proud of what you guys are doing. Okay, somebody else, step up. What do we do now? I need somebody else. Isabella. Divide by 22 on both sides. Okay? Keep going.
I don't know the answer
Alyssa?
Negative 6.
What's negative? Talk me through this. What's happening?
Y equals negative 6.
How'd you get y?
Because 22 divided by 22 is 1.
1, good, 1y. So the y comes down. And then you said negative divided by a positive is negative. And what'd you get?
6.
6, 2. Good, I like it. So now I have y equals negative 6. I'm done. Woo, woo! Come on, Emma.
You're not done because it has to be in order here.
Okay, so I'm done. Woo, woo!
You need to get your x,
Okay, so how am I going to do that?
and you can rewrite whichever equation you want.
Which one do you want to work with?
The bottom one.
Good choice. Now, listen. So I'm going to compliment Emma. Emma chose the bottom equation because, here's why I'd compliment her. Smaller numbers. I would rather deal with smaller numbers than bigger numbers. Okay, so I'm going to rewrite this. 10x.
And they're not,
Plus.
they're not any negatives in the second equation.
Yep. Okay, so Emma, keep going.
So now you have to substitute the y, so it would be 10x plus 3 parentheses negative 6 equals 22.
Good. And now we have to solve an equation, right? Okay. Somebody needs to walk me through solving an equation. I've lost my black marker.
What marker?
My good black marker, but that's all right. Okay, go ahead, Bianca.
Okay, so, the parentheses with the -6, you're gonna multiply that, and that's gonna be -18.
Very good.
And you're gonna bring 10x down,
Good, Bianca.
equals 22.
So far, so good.
And then you're gonna add 18 on both sides.
Excellent.
And then you're gonna get 40. 10x equals 40.
Bianca, so far, so good. Finish it off.
Divide 10 on both sides,
Okay.
and you get 4.
So x equals 4. Am I done there?
No, you're gonna put it in the order pair.
So I get 4 comma -6.
Hey,
Ladies and gentlemen.
Teamwork.
That was fantastic, folks.
Well done.
That was fantastic. Okay, so there's about 8 minutes left in class. That gives you plenty of time for your one and only one homework problem. You will need to copy it down. So here's your homework problem. Bless you. There's my marker. I found it. Miss Armstrong. I found it.
I'm so happy.
Me too.
It's very.
It makes me pleased when things work out. Let's go. Okay, here's your problem. 8x plus 11y equals 20. 5x minus 11y equals -59. This is the problem that you are working on. This is your homework, your only homework problem. The video, as always, will be posted, but here is your problem. Do it. It's homework. Yay!